Welcome to Ultrasound Physics Lab Session 5. Today the subject will be transducers. We've got a lot to cover. Let's get going. Okay, probes and transducers, same thing. What's a transducer? A transducer changes one form of energy into another form of energy. Like a lamp, electric energy to light energy. Like a gel warmer, electric energy to heat energy. You get the picture. So an ultrasound probe changes electric energy to mechanical energy, and then mechanical energy back to electric energy. Let me give you a brief history of ultrasound transducers.
Early ultrasound images were bistable, black and white only.
In the 70s, grayscale was introduced. The dynamic range improved.
This is what an ultrasound machine looked like in the mid-70s. The image on the far left is the electronics and control panel. The image in the middle is the transducer. It consisted of an articulated arm with a transducer on the end. To create a sagittal image, you would slide the transducer inferior or superior along the patient's abdomen. To create a transverse image, you would position the arm on the other side of the patient and slide the transducer from left to right. It was a static image. There was no real-time or video. The transducer is that little white cylinder at the end of the articulated arm. To change frequency, you simply unscrewed the transducer and screwed on another one. Here are some images I took as a student in the late 70s. Notice the images are black on white. In the early 80s, they switched back to white on black. In the late 70s, real-time was introduced. It usually consisted of a single crystal that moved back and forth. The probes were rather large, and they often vibrated. Modern transducers consist of arrays of crystals. The sound beam is electronically focused and steered.
In our lab we have curvilinear, linear, and sector. Let's start with the curvilinear. Technically, it's a convex probe. Its shape is a blunted sector. It's able to perform 2D, color flow, and pulsed spectral Doppler. We use it to perform mostly abdominal and OBGYN, and it's a 1 to 6 megahertz. It comes in higher frequencies for pediatrics, a little bit smaller. This is a 9 megahertz linear probe. We actually have two types of linear probes, vector and linear sequential. This is a vector. We know it's a vector because it has a trapezoidal image shape. Here's a thyroid on a vector probe. It starts off rectangular, but you just hit the virtual convex button and you get the trapezoidal shaped image. On the Philips, they call it wide scan. On the Siemens, they call it trapezoid. The Toshiba has a couple of linear probes, and they're probably linear sequential because the image is rectangular only. All the linear probes can do 2D, color flow, and pulsed spectral Doppler. Next, the sector probe. It's a phased array probe, technically. We use it for echo and for cranial. The sector probe, which is a phased array probe, is the only imaging probe that can perform continuous wave Doppler. The sector probe has a sector shape and can perform color flow, pulse Doppler, and continuous wave Doppler. Usually in cardiac, when you have high velocity flow, you also use the Pedoff probe. The Pedoff probe is a non-imaging continuous wave transducer. It has two crystals, one for transmitting and one for receiving. I have no idea what Pedoff means. Transvaginal probes are essential in any lab that performs OBGYN exams. Since they can get closer to the area of interest, transvaginal probes are higher frequency and higher resolution.
When using a transvaginal probe, it's essential to use a disposable probe cover. This is a trophon disinfection device. After the transvaginal exam, high-level disinfection is performed. Another type of probe is the hockey stick probe. It's high frequency and is used for superficial applications. The T-probe is an intraoperative probe. During surgery, the surgeon uses this probe directly on the liver's surface, usually looking for metastases. This is a typical probe cover used for intraoperative and biopsy applications. Large departments use a variety of probes and often store them on racks.
The PVR machines have continuous wave pencil probes. It's 8 megahertz. It's for superficial vessels. Also, PPG monitors.
PPG is photoplethysmography. It uses light to detect variations in blood volume. It has a readout similar to a continuous wave Doppler. Similar technology is used in oxygen saturation monitors.
Well, that's it for today. Stay safe, and I'll see you next week.